Welcome to the webinar of NEMOSINE project. Today we will have a very interesting webinar of 2 hours where we will talk about the NEMOSINE project results, expected results, and the status of the research that the consortium is carrying out. And then we will have a very interesting presentation with a special speaker that we will talk about the technologies that they are already implementing in their organization using other kind of boxes for the kind of film that are actual modern films. I will share my screen now just to introduce a little bit the meeting of today, the webinar, and to share with you some information about the project. So, NEMOSINE project is a research and innovation project funded by the European Commission. It's an Horizon 2020 project aimed to improve traditional cultural heritage storage solutions to preserve visual and audio material by developing an innovative package with the primary goal of energy saving and extend conservation time of the films. The project started in February 2018 and is expected to be end by January 2022. The consortium is composed by a large typology of organization. We have large organizations, research centers, small and medium enterprise, and also we have end users involved in the consortium that are the archives that will test and already provided the requirements of the technologies that they need for the preservation of the material that they have in their own organizations. The agenda of today's meeting is composed by 5 specific presentations. We will have the coordinator of the project AIMPLAS, the coordinator organization AIMPLAS, that will talk about the NEMOSINE project, the roots and the conservation, the new routes for the conservation of films and other artifacts based on cellulose derivatives. Then we will have a BESKIT Plus, that is one of the small and medium enterprises involved in the consortium, and will provide their view about an innovative storage solution for long-term preservation of fragile material. Then we will have our special guest of today. This is an organization not part of the consortium, but is very well related to the topic of our project, and they will talk about their film that is a digital preservation medium, and the Arctic World Archive that we will see later in his presentation. That is a very interesting way to preserve film materials. Then we will have again a speaker from BESKIT Plus that will talk about why or how box can change the way people are storing contents. Finally, we will have the presentation of PNO, that is another organization, private industry organization involved in the project, that we will talk about the innovation impact assessment expected for the project results. Today, we will have the following presenters. We will come with Susana Otero from AIMPLAS. She is the head of engineering from the group of AIMPLAS, and she has more than 10 years of experience in process controls in press and pre-press, implementation of graphics standard and color management. She is the technical project coordinator of the project at NEMOSINE, and she will share with us the intention of the expected results of the project and the research, innovation research that we are carrying on within the framework of the project. Then we will come with Andrea De Polo. He is representing the organization BESKIT Plus today, and he is a senior manager focusing on supporting organization digital transformation journey. He is a head of digital transformation, and he's collaborating in building a strategic partnership, supporting multimedia, content advertising, and education ecosystem. Then we will have Alfredo Trujillo from the organization PQL, and he is the product manager of PQL. He has worked in that company since 2014, and he played an important role in launching and managing the product. So it will be very interesting to come with his point of view also about the NEMOSINE expected results in the market. Then we, at the beginning, until today, well, we expected with the participation of Bartosz Barbiarz, also from Beskid Plus, but unfortunately he is not able to attend today due to health problems. Unfortunately he is sick, so Andrea De Polo from Beskid Plus will replace him. And then we will have Luigi Ranza from Chautec PNO group. He is graduated in engineering at the Polytechnic of Milano, and he worked in the field of innovation managing. He has a significant experience in the LCA and the LCC analysis, and then he will provide in his presentation the impact assessment of the product, the NEMOSINE product. As you saw, the agenda is well, is rich of contents that will provide the market point of view for the results and H2020 project, of an European project, and the way to introduce this project expected product to the market. So we really appreciate your participation, and then we have to share with you some information. Please notice that this training will be recorded and will be publicly available, so you will have the chance to see it later or to share the link with your colleagues or contacts later if you wish. You as attendees cannot speak and you will not have the opportunity to share your screen, but if you have any question, please write directly in the chat. So the presenter will answer the question in the last round of the webinar, the round table, that will be the special space for the question and answer round. So we are not taking more time of this webinar. We keep here the information about how to get more information about the project on our website, on the LinkedIn account, and on Twitter. So please, if you are interested to get more information and to keep updated about the progress of the last month of this project, don't hesitate to contact us or to be linked in the social medias. For further information, you can contact me, Carolina Salas, or Maria Jimenez, that are my colleagues from PNO Consultants in Spain. And, or you can be in contact with the presenters, that his contact information is available in their presentation, and will be also available in the NEMOSINE project website. So thank you very much for your participation, and I will give now the floor to the first speaker, that is Susana Otero. Okay, Susana, did you receive the invitation?
Yes. Thank you very much, Carolina. Thank you for your presentation. Well, so we have started with the training of today. The aim of this first presentation is to, I can see my screen right now. You can see, I can't see my presentation.
I can see. So.
Okay, so we will see in this first presentation the new rules for the conservation of films and other artifacts based on cellulose derivatives. First of all, I would like to introduce about the problem and the need that we try to cover within the NEMOSINE project. The first fact is that cinematographic works are an essential component of the last century cultural heritage, not only in Europe, but also all over the world. In addition to their cultural value, cinematographic works are a source of a historical background of the evolution of the European society. They provide a comprehensive record of the richness of European cultural identities and the diversity of its people. So, photographs and posters and films are part not only of our cultural heritage, but also about our historical memory. In order to ensure that European film heritage is passed down intact to the future generations, it has to be systematically collected, catalogued, preserved, and restored. But if we focus in cellulose-based cultural heritage material, film archives is around 18 million of film reels, and 5% of them are in a critical stage or showing signs of vinegar syndrome. So we have different ways to, or different routes to preserve all of these cultural heritage. Conservators consider two approaches when planning treatments to extend the useful lifetime of cultural materials: preventive or passive, and active or interventive. But in case of cellulose derivatives and other components of movies or photos, once has been initiated this problem, the degradation cannot be prevented, preserved, or stopped, but only inhibited or slowed. They have had other technical approaches to solve this real problem that follow the line of replication and copy the original ones in modern digital supports, but they don't give the possibility of a real preservation of the original ones. For that reason, in the NEMOSINE project, we have working to develop new solutions that support to increase the life extension of this cultural heritage based on cellulose derivatives. In fact, the key objectives of the NEMOSINE project, by developing an innovative smart package, are first of all to compensate the lack of cool and freeze storage for cellulose-based cultural heritage materials, increase the life expectancy of cultural heritage objects when storage conditions are insufficient, too warm, too humid, and so on, to monitor systematically the chemical condition of the cultural objects, precise knowledge of the condition of the collections, and to develop a prediction model for deterioration. We have found new routes to help the cultural heritage preservation within TICS technology and also nanotechnology. So if we focus in the main NEMOSINE concept, the aim is to improve the traditional storage solutions by developing a new packaging with the main goal of energy saving and extend conservation time. In fact, we have focused in the project to develop new solutions to absorb the acetic acid emitted by this cultural heritage based on cellulose materials. On the other hand, we have developed different solutions to monitorize, to detect the emission of acetic acid and NOx. In parallel, we have developed multi-scaling modeling, and the final aim is to integrate all these new functionalities in a new film package with modular design to make it easy for the archives to monitorize the state of the films, in combination also with curative packaging, in order to avoid the problems derivative of humidity. Here you can see the main technologies that are in the base of the NEMOSINE project. In one hand, regarding acetic acid absorption, the partners involved in these activities they have developed new materials, new nanomaterials, in that case MOFs, functionalize it to absorb acetic acid. On the other hand, the partners involved in the TIC solution have developed also sensors, new sensors, to detect the emission of acetic acid and also of NOx, to analyze the emission and to develop a predictive maintenance action to analyze the degradation process and to monitorize. Together with a modular wireless communication in order to make easy to obtain all the data from the archives. You can see here the partners composition of the project to work in this different technical approach to develop these MOFs and how to integrate in different materials to integrate this functionality in an easy way inside the final packaging. Also to develop these sensors and wireless communication of the emission and degradation of the films, and also, well, together quite close to the archives, 3 archives that, well, they have given us all the technical specification, and they are validating this technology in their facilities. So these are the main research areas in which NEMOSINE is focused on regarding acetic acid absorbers based on MOFs, also antifungals materials, sensors and wireless control, and degradation model software. All of that will be integrated in Fieldbox to develop a smart box that then VestKit Plus will explain in more detail, to integrate all the functionalities to make an easy solution ready to use by the archives. Here you can see the MOFs that has been developed in the field of the project for the acetic acid absorption, and one of the structure of this MOF in pellets to integrate easily in different ways in the field box. We have also made a lot of research of how to integrate these MOFs inside different carriers, such as PU foams, nanofibers, nanocellulose foams, impregnation, cellulose membranes, etc., and woven, non-woven, in order to integrate these new foams, these new MOFs in a carrier to integrate this functionality inside the field box. Also, you can see here the electronic PCB with the oxygen and NO2 sensor and acetic acid sensor in this PCB, together with a wireless communication module to obtain all the data regarding the degradation of the film, well, regarding to the emission of these gases. And also it has been developed a degradation model software to monitor the degradation of the field and a control platform in order to make easy for the archives to track and to monitorize all the information, the relevant information of the status of these cultural heritage films. And finally, you can see here the film box developed to integrate all the functionalities inside in order to make easy to handle and to manage by the archives. So you have seen a close idea of the NEMOSINE project and the new routes we have followed using nanotechnology, using TICs, in order to find new ways for the preservation of the 20th century cultural heritage, in that case, films. Thank you very much for your attention. That's all for my side.
Thank you very much, Susana, for your presentation and for all the information that you have shared about this technology. I would like to remind to the attendees that if you have any question, please write the question in the question session panel. And at the end of the webinar, we will have the opportunity to ask the question to the speakers and to provide the answers. So to follow with the presentation, I will share my screen and I will introduce the following speaker. We will have now the presentation of Andrea De Polo from Basket Plus. He will make a presentation about the, okay, Andrea, hello. Andrea will present, make a presentation about the package. So his point of view as a small and medium enterprise about this NEMOSINE expected solution. The title of his presentation is An Innovative Storage Package Solution for Long-Term Preservation of Fragile Material. Thank you, Andrea. Welcome.
Good morning. Thank you, everyone. Can you hear me well?
Yes.
Okay, so thank you, Carolina. This is Andrea De Polo from Beskid Plus. Beskid Plus is one of the most important, well-known photographic film boxing preservation SME based in Poland. The reason why Beskid Plus is involved in the NEMOSINE project is because we believe that this solution provided with the European funding from Horizon 2020 is absolutely a very interesting solution for long-term preservation in the cultural heritage sector. So my presentation will go over these specific points in the agenda. So why NEMOSINE, the real innovation of the project, the market needs, an opportunity around the corner, and what next. So my presentation is not, I would say, from the research, but more from the industrial and from the cultural heritage market needs. So why NEMOSINE? As it was mentioned before by Susanna, this project has been founded because the European repository of cultural content is still in peril. Peril because we all know that the chemical degradation of film and photography is always happening. There is no a real magic solution to prevent this to remain the material as it is, for forever. However, we will hear after my presentation actually a very interesting solution from Pickle from Norway, which will provide a very interesting solution that should assure the preservation between 500 to 1,000 years. But NEMOSINE, anyway, can be the answer. The answer is because in a world where, for example, according to this study, more than 5% of real films are still in critical conditions because the vinaigrette syndrome, because the acidic reaction, because pollution that we know how much it affects our world and our storage. NEMOSINE is trying to provide a solution that is going to prevent more than cure the precious content from ultimate degradation. So the key objective of the project is to provide an innovative smart packaging solution. And this is one of the reasons why Beskid Plus, which is a company that is producing storage boxes, has joined the NEMOSINE project. So my presentation is focused mainly on the requirement and the expectation from the cultural institutions like museums, galleries, and film archives, and why those institutions are looking for a solution like NEMOSINE to protect their precious heritage. So the real innovation of the NEMOSINE project is to create this smart packaging with a high O2 barrier and active packaging that are put together in these final preservation boxes. Very important is also to use gas detection and sensors. This is something that is truly innovative in the industry, and because this project has been funded through the nanotechnology European framework program, NEMOSINE is the right project for this tender. In this last period of activity of the project, it's also very important to explain to the audience that the project is not only focusing on the sensors and the technological solutions to find the right way to reduce, to detect these chemical changes inside of the boxes, but according also to the user requirement, to the feedback from the end users, from the cultural institutions. The project is also focusing in the last few months on the best and the most efficient design in order to make the handling and the strength of these boxes as clever and efficient as possible for film archives. So this is a short summary of the NEMOSINE approach with those sensor devices, this external durability plastic layer, and the multi-layer packaging. In essence, those boxes are made by 3 layers with these inside sensors that should provide to the museum curator or to the institution on a real time the situation, the status of the chemical condition inside of the box. And as I said at the beginning, prevention is the real key and the real solution according to the NEMOSINE philosophy to help institutions to optimize their cost, to extend the longevity of the film, and also thanks to NEMOSINE to support to make new jobs, to create new opportunities in the cultural heritage framework. So the market needs. As I mentioned at the beginning, my presentation is mainly focused on the user expectation and the requirements. So during the project, we have done in NEMOSINE also some internal and extending questionnaire and evaluation test with end users and with institutions in order to size and to make those boxes as pertinent and as specific as possible for the cultural institutions. So we ask questions about pricing, about the weight of the boxes, about the shape of the boxes, about what are, for example, the most common degradation issues that film institutions face today, the temperature and the humidity conditions, and of course, where they are today, where they would like to be in 2 or 3 years by using, the NEMOSINE solution. And those are some of the statistics of the numbers that we have collected during our initial test and early assumption studies. These boxes also have to face a big challenge. In Europe, we have a very heterogeneous, but not only in Europe, although Europe is very rich, it's probably the richest continent in the world. We have very heterogeneous materials. So we have a film, we have a film on acetate, but we have also glass plate negatives that sometimes can be as big as 1.5 meters in size, like this one in the picture. So you understand that whenever you have to make a preservation project, you have to have this strategy, and you have a very complex, heterogeneous film or photographic archive, heterogeneous in terms of dimension, in terms of material, in terms of different period with a different deterioration problem. the plan, to make this strategy as effective and efficient as possible is not easy. So one of the tasks that Bescript Plus and the NEMOSINE project has also tried to fulfill was to make the project also economically driven, and also to try to accommodate all these different kind of heterogeneous material available across the different countries in Europe. Today, we still face, unfortunately, in Europe, a lot of complex storage situation, and even very prestigious film and photographic archives still preserve their content with old, with poor quality card boxes. So the answer of NEMOSINE is going to provide also from a market and industrial approach, a solution that will be economically driven and that can be easily translated into a real concrete project across Europe in order to help even small and institutions that don't have a lot of money to preserve their material in an efficient way. So the conclusion and the suggestion according to this presentation and to the NEMOSINE studies is, of course, to keep the temperature level as low as possible. We have to be to face, of course, also the economy and the cost to keep the storage conditions very, I will say, even across the year. So according to the project, to keep the temperature between 8 to 16 degrees Celsius is good. But of course, according also to the PICL study, to the general study in the industry, the lower you go, the better it is. So I say 8 to 16 is the minimum, but if you go lower, it's better. Last but not least, of course, the relative humidity has to be also constant all over year long. And again, the recommendation of the NEMOSINE project to be between 35 to 40, 50% is the best recommendation. We have some opportunity around the corner. According to this study from Japan from September 2021, the film industry market is still exploding. So there is going to be in 2022 55 billion of grow in the film industry, with an improvement between 2017 to 2022 of 4.2%. So more the boom of this film industry in Bollywood in India and Hollywood in America, for example, is excellent for the industry. But of course, so we have also to be sure that the preservation and the storage archives are also ready to keep, to hold and to host all this huge new quantity in the most acceptable way. And also the international standards for film preservation are now adopting new recommendation, including the photographic activity test, the ISO, and the ANSI standards, to the latest regulation, also in terms of ecosystems, to make the whole storage solution, I would say, more eco and green friendly. So what's next? One of the objectives of NEMOSINE is to provide not only a solution that is economically driven, but the design, as I mentioned before, has to be clever, has to be optimized, but also has to support long stress usage. This is absolutely very important. We have to fulfill to meet the ISO and ANSI standard. This is absolutely essential in order to be accepted around the globe. And it's very important that the NEMOSINE project is built and has been created from ground from institutions that are in the cultural heritage and the preservation sector. So everything that is done in the project is also with this recommendation from the end users and from the industry. So we believe that those sensors and our solution, which is not available today anywhere else, has definitely a place in the market, and we hope that Basket Plus will help the NEMOSINE project to deploy, to promote and to uptake this solution in the mass market in the near future. So thank you very much for your time. This is my contact details. So if you have more questions during the meeting or afterwards, please contact Susanna, Carolina, or myself. Thank you very much.
Thank you very much, Andrea, for your presentation and for the detailed information that you have shared about the interesting of having the NEMOSINE solution soon in the market. Now we will have the opportunity to hear the presentation of our special speaker of today, that is Alfredo Trujillo from the organization PyQL. The title of his presentation is the PyQL Film, a digital preservation medium, and the Arctic World Archive. So, Alfredo, I will give you the floor to start with your presentation. Okay.
Thank you, Carolina. Let me just... Okay, you're seeing my presentation, correct?
Yes. Thank you, Alfredo.
Okay, thanks again, Carolina, and thanks to the NEMOSINE team for inviting me, and also in representation of PICO. Also nice to present our solution that is very similar to NEMOSINE. We want to preserve cultural heritage. We preserve digital information. NEMOSINE is looking to preserving already art that has been put on film and in different mediums, but it's very similar objective. My name is Alfredo Trujillo. I'm product manager of, as I mentioned, PICO. I'm gonna talk about two components on our solution, which is the PICO film, which is the core component in the preservation, and we have also a physical vault in the north, close to the North Pole, that is called Arctic World Archive. We call it AVA. So let me dive into that. The first, who PICO is, we are a company, we are service providers in the long-term digital preservation market. We have created the technology to provide this solution. And historically, this started with a Norwegian entrepreneur, is Rune Bjerkestad. He is starting, I don't know if you see the machine next to me. He did this innovator. It was a machine to make masters and distribution copies for the digital projectors in the movie industry. But of course, around 2010, I think, when the cinema was digitized, he was looking into what do I do with this technology. He identified that there was a problem with the preservation of digital material, and we have a lot of experience on film and transferring digital data to film to make analog images. So why not to use that to put digital information? And that's how it started. The good thing is that we also, as NEMOSINE, we were lucky to create some consortiums, and we were awarded with several European projects. One of the, initially with the Eurostars and some local Norwegian projects like the Norwegian Research Council, and later we were lucky also to get the Horizon 2020. So it's very similarities. Now we have the solution in the market, so we are providing it. Okay, but what is the core? I mentioned the PICO film. This is an offline call preservation medium. And we have combined it with certain characteristics that allow us to be secure and also migration free. I will explain that a little bit. The picture you see here is the PICO reader. It's the system that we use to decode the information back. So this is one of the key elements in the solution when people want to have the digital, the files back. As I mentioned, what have we done? We use this analog, well-known medium, which is the black and white photosensitive film, 35 millimeters, and we just expose digital binary data. So we take the the files that come from the customer, we encode it in frames, and we expose in one frame on film at high speed and in different levels of grade, which gives the value of the binary code. So we can put anything, databases, any type of file. We design in one other project, the ones that I mentioned, the European project, we designed the pickle film, this black and white film. I will explain a little bit why. We call it nano film, and we also did, as NEMOSINE, an enclosure. Of course, we're some years back to NEMOSINE, so we didn't know what they have. So we created that at that time, and we did some studies to ensure the longevity of the product. You might ask, well, what is this pickle film unique and different from what is in the market? So the uniqueness actually is what we call the self-contained. So for archivists, it's very important to find a medium in the future and be able to recreate the technology without the need of anything like pickle or any other special technology. So this self-contained, being an optical, the film being an optical medium, we can write instructions. We can put the source code of the software that can open those digital frames. We can also put digital readers, file format specifications. If you, after decoding the binary data is a PDF-A, we can put the reader, so an engineer in the future can recreate that software and open the PDF-A. So that's the way we have gone to the market, and it's unique when you compare it with DVDs or you compare it with hard drives or magnetic tape. Besides being a well-known preservation medium in the microfilm industry and the motion picture is unalterable. We cannot change the data. It cannot be hacked. It cannot be affected by virus. It doesn't use electricity for keeping it, and especially in the artwork archive that I'm going to mention later. And it's a cold storage medium, so it's very, very fun, very fine. Another thing, you might think, okay, this is a storage medium that I put in a corner, but for us it was very important to create a holistic solution in which our customers can access in an online way to their repository. And that's what I mentioned, the IT environment integration. And just to mention very fast, we create a platform, software as a service, we call it archival as a service, where a customer that wants to create a repository can just ask for the services. So that person in front of the PC and in a user interface just upload files. I say, I want to preserve this. So they don't see the technology behind. At the end, what they receive is a pickle film they can store locally, or they can pay local services in a vault, or they can use the artwork archive. And that's what you see in the bottom right. We can provide that physical extra security layer on the pickle film. And that's the Pickle Connect. And in the same way, when you need to retrieve the data in the future, you just search for your data and you retrieve it online. Somebody is picking up on the background the film and restoring the data, but you just in front of your PC waiting for that file. So going back to the technology, we call these bits on film. Well, we have three components. Basically, this is what we developed during this research project. Is the pickle writer, which we expose the frames on film, and we use a digital micromirror device where we modulate the light, so we have 8 million pixels. So every single pixel is the data container, and we have different gray levels, so we can differentiate the value. We basically, easy way, if you think in a QR code, but it's a high density QR code, and actually you can see it. Then you send it to the pickle processor. There is a normal black and white processing, chemical processing to make the image permanent. We have made some improvements in the throughput, so we can go faster, but it's a typical process for developing film. And we have finally the pickle reader, that the machine I showed at the beginning is the platform to verify. So when we have done the film, it needs to go to 100% verification, where we decode the files, we analyze the checksum of the file, and we compare it with what the customer gave us. So we can say, okay, this is good, then we can send it to storage. We also use that machine for the retrieval process. When you go to your site, you say, everything has gone bad, I need some file or several files, you can choose, and then we use the same machine for retrieval. The machine use technology that is available today. You just need to take a picture of the scan, In this moment, the pickle reader is optimized, but you could take a picture of the frames, create the software, and then decode it. This machine does this at high speed, scan the frame, and decode it in real time. So this is the core of the technology. If I go back to the offline storage medium, the difference with NEMOSINE is that we are not working on legacy art that has been done in the past. We use our polyester film where we create, it's a PET 100 micron thickness material. It's a black and white negative film, so it's very similar to what you find in the market. But when we were looking for a film, we went to the traditional manufacturers, Fuji, Kodak, and we couldn't find a film that had the resolution that allow us to put small pixels and be able to differentiate when we scan, to oversample. So what we did, we started one of the research projects with 2 film manufacturers, and we create a fine grain. They highlight the silvers are to the nanometer level. And that's why we say nano film. And we create a high resolution. And also we did some tests on the polymer on life expectancy. I will come back to that. And that's what we call critical film. Very important, we needed to give this robustness and resilience, because we are talking now no visual images, you're talking about small pixels that represent data. So what we did, we applied the same forward error correction or redundancy algorithms that you find in DVDs and hard drives. So we applied to our encoding. So we have redundancies within a frame and also along several frames. As you can see in the picture, we can lose 1 frame in 200, and you can retrieve the files. We can build them. We do read-back stress tests where we scratch the film, and you see to the right, and still we can. It's no problem for us. We can decode it. However, this film is kept in conditions that is not manipulated, so it's not going to have many mechanical forces. But anyway, we need to do it, and we can prove that it's very reliable. So this is very important mechanically. What I mentioned is also we do this longevity. We make a partnership, or not partnership, but we use in one of these projects a company that is Nurner. It's a Norwegian research institution, and they use ISO standard for calculating the life expectancy of our film, and also the box, and also the label. They use heat chambers where they use different temperatures, they control the humidity, and they put that over time. When it breaks, they can extrapolate and find out what is the lifetime at 21 Celsius degrees. They also do mechanical tests like elongation or when it's snap brittleness. And in the meantime, during that process, we also read, when it's aging, we read back the film, and then we can demonstrate that it's possible to retrieve. In that way, we can say that it's more than 750 years right now. You see some pictures behind when we test the box with the film. We put in aluminum bags and some processes hanging film, and then we do long-term and short-term life expectancy ISO test. When we look into the how we store the pickle film, we call it pickle box, and this is our container. It's not NEMOSINE, but we have we're looking at very amazed to what they have done. I will mention something later, but what we did is looking into what kind of materials that didn't interact with the silver on the film. So we did a lot of testing. We use our polypropylene, as you can see, PPB2. We also look into the label and the design of the box. For the label, we use PET, and we use a process called thermal transfer printer. So it's not easy to scratch. You almost can, and the material you almost cannot rip it off, and then you cannot even take it out. Okay, sorry, I see some messages, but we'll take this later. Okay, so on the right, you can see the picture of the pickle box, and you see in the bottom that the core of the box is attached to the bottom plate. So we can manipulate easy, and it doesn't fall, because we also, when we wind the film, we call it a preservation tension. So we don't do it very tight because it's good for preservation. So it's good to have the the plate, and it's easy to manipulate, and then you snap the box. The box is against dust and water splashing, but it's no seal. We do other things I will show later. This takes me to the artwork archive. This vault that we have created as a safe repository, and our goal was to provide to clients in the cultural heritage, and also there is private companies that want to keep that film in a secure physical vault. So the vault is located in a Norwegian island. It's called Svalbard. It's in the north of Norway, close to the North Pole. It's in an abandoned coal mine that belongs to the coal mining company owned by the Norwegian government. So the good thing is that Svalbard is declared demilitarized. It was a treaty which gives the sovereignty to Norway. So it's very safe, secure place. So we use the mine, and we also need to look at what were the environmental conditions within this ABA. So we designed the storage to fit with the ISO 18911, following the practice for storage of photographic films. And we also engaged the Norwegian Defense Research Establishment to do our environmental characterization, to analyze what was the environment within the vault. They detect there was low levels of oxygen, which is good. There was a very natural ventilation, so reducing accumulation of gases. The good thing is that all year round we are in permafrost, so the temperature is constant at -5 degrees. The mine is dry and cold, but humidity can increase a little bit, so that's why we have done some things. But there is no rain that is filtering into the tunnels, so this reduces the concentration of microorganisms. Also, we look into radioactivity, because the coal can contain radionuclides that can affect or degrade the ground surface, but it's completely clean. There is no waste coal. And also the pickle box is in a steel container that provide this extra shielding against radiation. So they did all that. Then the other thing we did with the pickle box, we bag it in an aluminum bag. So we make a customized bag that is 3 size sealed by the provider, and then we seal with a special method the front. So we have proven that air don't enter. We also, when we bag the films, we do it in a controlled environment, so we can have an extra protection against probable environmental particles, microbiological attack, dust, and things like that. So we have it in the ABA vault. You can see across section on the right, where you can see that the aluminum foil is 10 microns, and we have other layers to provide other characteristics like puncture, flexibility, things like that. And Nurner, who is this research company, also do some test conditions, assuming that in 1,000 years, if the temperature increased to 2 degrees, assuming the relative humidity is 0 inside the bag and is 100 outside, what will be the transmission of water into the pickle box, and the calculations were 1.787 grams per square meter, which is very, very low. And here, when we contact the team from NEMOSINE, we start looking into the project, and we think it's very interesting, especially for us, the monitoring part, the sensors, and we see that it's very modular, so maybe sensors can be changed in the future. So even though we're not working with cellulose derivatives, polymer is very stable. It's still the humidity, the change oxygen, so it might be very good to monitor. So that's one of our interests that we could see in the future. So and it's good to engage with the team. And this is what I have for you today. Just summarizing, the good thing is we use the black and white nice preservation quality of this film, and then we blend it with digital technologies. We create the platform around so people can interact with that. So it becomes your ultimate backup. It's just like a normal storage medium, but better. Okay, that's everything for me. Thank you very much. Anything?
Thank you very much.
Yeah.
Thank you, Alfredo. Thank you very much for your presentation. Personally, I like it very much, the ABA place where you have the conservation. It's very interesting to know, and I would like to have the opportunity to visit it.
Okay,
well,
welcome.
if I take the opportunity to remind everybody, if you have any question, please write the question in the panel of questions, and at the end we will have the opportunity to reply and to have the answers from the speakers. Now we have the agenda. We have now the presentation from Basket Plus, from Andrea De Polo, because unfortunately today we cannot have the presentation of Bartos due to sick problems. And Andrea will present sorry, I'm trying to connect Andrea. Okay, Andrea, so you have now the floor to introduce the presentation of Bartos about why and how boxes can change the way people are storing contents. So it is interesting to see also the Basket Plus point of view after the presentation of PQL from Alfredo.
Yes, thank you again. Can you hear me? Can you see my presentation?
Yes, thank you.
Okay. So the title of this presentation is Why or How Boxes Can Change the Way People Are Storing Contents. The presentation was made originally by Bartosz Babiarz, who is the Basket Plus marketing manager, and I'm going to represent him as I'm cooperating with Basket Plus as well. As I said, Basket Plus, it's a box preservation producer, a company from Poland, and they are very interested in the project to see how they can bring this solution in the real market. And this presentation again is focused on the way that those boxes can change the way people are storing boxes. So let me go over a little bit about the background of storing solution in a proper way. The storage can be done on different ways. There are different ways to preserve material. It can be done on boxes, on different rooms, on different buildings, on different even situation and conditions. Archivists, librarians know for a long time, for centuries, I would say, that storing fragile material on special enclosures will extend the lifespan of this material, and especially if we use protecting a mylar, specific folders, and for example, acid-free jackets and board, acid-free board. This will also protect the inside material from the lighting, from the chemical reaction, because acid-free should a little bit, I would say, mitigate the chemical reactions, and we also keep the dust away. However, as I mentioned also in my previous presentation, there is no magic today. We can only decrease the ratio of accelerating this decomposition situation. Definitely, the solution provided by my friend Alfredo, by Pickle, is probably one of the best, because by keeping the boxes inside under the permafrost in Norway is definitely a very clever way to reduce, to extend the lifetime of this material very, very long. But it's also important to consider the boxes, and again, NEMOSINE can provide a perfect solution, or probably by combining NEMOSINE boxes with the Pickle approach might make your arsenal strategy as efficient and clever as possible. We know that for proper storage conditions, the acidic compound are probably the most enemy in our chain, because they can affect the cellulose, I will say the first substrate of the film and the photographic paper. And in books, for example, in old books, when we have this chemical reaction, we start to see the pages turning brown or brittle at the edges. And those, when you see those kind of visual effect, it means that unfortunately the chemical reaction have already started, the oxidation or the acidic reaction have already started, and sometimes entering into the game at that point might be too late. So again, it's very important to try to cure, try to prevent this situation before it become too late. So in the NEMOSINE project, also through the Basket Plus strategy, we are focusing on two important ISO standards, the ISO 9706 and the 16245, in order to make sure that the durable paper and the packaging for long-term preservation are met in an effective way. The best way to keep this material properly, of course, is to use always archival components. Archival components, again, is a very broad term. Sometimes you find in the market material that claim to be archival savvy, archival museum archival certificate material, but it's not always the case. What we would like to highlight in the NEMOSINE project, that, as I said again, the project has been built from ground with research institutions, but also from museums, from film archives, from box film productions institutions. So whenever we are using a plastic material from AIMPLAS or from other institution, everything is done by using the most certified with the highest quality possible material available today in the market. This is absolutely very, very important, and this is again why also Basket Plus is in the project. We believe that a proper storage solution also can help archivists and museum curators to keep the material free from the dust, and so you also save time and money in cleaning and in the restoration process. So the proper storage solution for collection, we know that the humidity, the temperature level is often a critical issue in our buildings. To keep the temperature and the humidity constant all year long, it's often a problem. And again, we go back to pickle, because probably by using a solution that is placed under the permafrost, also in a zone, in an area that is neutral, that there are no conflict, that the East and the West have found savvy for many scientific also purposes. I think it's a perfect way, a perfect strategy, not only for pickle, but also for people that are interested on preservation and on building the right methodology to preserve their collection, to consider a solution like that. So in our vision, you have to be careful about the mechanical degradation, about the physical degradation. We have to prevent the mechanical damage, but also we have to slow down the negative impact of physical and chemical degradation and reactions. And last but not least, there are always risks related to flood and fire. So those issues we have always to consider, and we have always to be sure that we build a task force and a checklist that will reduce to the minimum those possible situations. So what are the advantages and disadvantages of this strategy? The advantage is we can use different construction, different material, different shapes, dimension. We can enclose, as I mentioned earlier, material that is glass plate negative with different sides, with different shape, which can be on film, on paper, 3D material, and that can be also assembled and disassembled very effectively. The disadvantage, traditionally speaking, is you have to be careful with flood and fire. You have to be very careful whenever you assemble and when you move or you transfer fragile material to one room or even through from one storage place to another. And the damage that you can do even by using non-professional handling or by using inadequate treatment in the restoration or preservation solution can really affect the conservation and preservation condition of your material. So we have always to be very careful to also train and educate your team to use not only the money, but obviously the technology and the conservation material in the most effective way. So according also to NEMOSINE studies, one of the objectives of the project is not only to build a long-term preservation, but also to educate the market, to educate the citizens, to educate, to inform also the decision makers in the cultural heritage sector, including, of course, also the project officers and the people at the European Commission, that is not only important to build and to have the right storage conditions and the best climate condition like in the Svalbard place, but you have also to educate the people and the citizens on the handling and to help them to understand about the importance that they have to act and to react to preserve and to keep this precious material that Europe is very rich in a very efficient and economically sustainable way as soon as possible. We believe that it's not only time is money, but the timing is against us. The climate is changing a lot. Unfortunately, we witness that the pollution is affecting our life. COVID is just an example where diseases can change our lifestyle. So it's very important to build as soon as possible a conservation and preservation strategy that can fulfill all your needs that can be built around a sustainable business solution that can help museums and institutions to preserve this incredible European repository for the future generations. I'm often referring to Europeana, today Europeana has more than 50 million 2D and 3D material that has been digitized and shared online through the Europeana portal. But again, without education and without promoting even Europeana in the right sectors and with the right decision makers, believe me, the money that the European Commission, for example, has invested into Europeana, or many European projects that have been built from scratch around the cultural heritage, will be a waste of time and money unless our message to build a very reliable and sustainable preservation ecosystem can be accepted and deployed at a mass level. This is absolutely a key. In this respect, for example, I can also highlight the unique solution provided by Zeucher. Zeucher can, for example, help you to digitize this precious paper and photographic material in a very fast but also high quality material. So there are also a company that today can help Europeana and European research project to build around, for example, a NEMOSINE box or a storage place like the AVA in Svalbard in a very efficient manner. And as a consultant and as an expert in the cultural heritage sector, I really want to share this message with the audience. Here are some examples of today available solutions for storage. So those are boxes for film. They might look attractive. They have this neutral gray. They are built on a traditional acid-free box, but the problem of those boxes, although they are acid-free, they are very good for storage, they are not extremely durable like the one provided by NEMOSINE, for example. So in my vision, from my personal perspective, I think that today NEMOSINE has an incredible opportunity to offer to the market a solution that has the same quality of those microfilms boxes, or those one that will preserve lamps or other kind of boxes, but in I will say in a more durable solution. Boxes can not only preserve bulbs or papers or maps, but even coins. This is again another solution provided by Beskid Plus. As you can see, whenever we're talking about cultural heritage, the material can be very heterogeneous, and there are different requirements, different expectations to preserve your material. So it's very important also as a box manufacturers or as a content owner to work with a company that can accommodate your needs, that can provide a personalized and customized design for your solution. Last but not least, since we are talking about film, this is an excellent storage solution where you can put these reels of films in these small containers. So this is the presentation from my colleague Bartosz Babiarca. I wish him a speedy recovery. I thank you very much, and now I pass again the floor back to Carolina. Thank you very much.
Thanks to you, Andrea, for your presentation and for taking the role of Bartosz and introduce the Beskid Plus technologies and other products. And now we have the presentation of our speaker from P&O, from Chautec, the Italian company of P&O Group. We have Luigi Ranza. and his presentation is about the NEMOSINE Innovation Impact Assessment. So Luigi, I will share with you I will give you the floor. Wait a minute,
okay,
please.
okay. Good morning, everybody.
Let me know if you have received the invitation as presented.
Exactly.
Okay,
I'm sharing the screen.
Luigi.
Can you see? Okay, okay. Thanks, Carolina, and thanks to all attendees. I'm Luigi Ranza. I'm an engineer, and I work in PNO, that is the leading European innovation management and grants consulting company. Within the NEMOSINE project, we have worked on the project impact assessment. That is a fundamental moment in the project, since the project impact assessment gives the possibility of evaluating the impacts of the project in the short, medium, and sorry, I have a problem with the presentation. Can you see my presentation?
Yes, I can see the presentation. We have in the page project impact assessment.
Okay, now I can see it again. And in the short, medium, and long term, and from different point of view. So the idea is to identify the environmental impacts. So the impacts, for example, on climate change, use of resources, and human health. The economic impacts, so for example, the cost effectiveness and the economic sustainability of the product and service developed within the project. And last but not least, the social impacts. So the product and processes, actual and potential positive as well as negative impacts along the life cycle. So within the NEMOSINE project, we have assessed all the impacts from all these different points of view, with the aim of providing a complete picture of the potential benefits for Europe and European citizens. Starting with the life cycle assessment, the life cycle assessment is dedicated to the evaluation of the environmental impacts of the project that, as we have seen in previous presentation, is a key aspect of the project, since the objectives, besides having the, let's say, cultural heritage conservation in a better way, the solution will provide also a solution with a reduced environmental impact. So the objective of the LCA is to determine whether the new package and technology developed within the project and that will be used by museums and film libraries facilities will lead to real environmental savings. So the LCA is a methodology that is developed in accordance with ISO 14040 and 14044, and allow to evaluate the environmental burdens associated with the product or process by identifying and quantifying, for example, the energy and material used, as well as the waste released to the environment and the emissions to the environment. So the idea is to assess the impact of these inputs in terms of energy and material uses and in terms of releases to the environment, and to identify and evaluate the opportunities for environmental improvements. So the life cycle has been applied within the NEMOSINE project to assess the environmental impact of the packages and technologies developed within the project. To give some more details about the methodology that we have used within the project to assess the environmental impact, the analysis is developed in basically 4 steps. The step 1 is dedicated to the goal and scope definition. So within the first step, we are going to define the scope of the analysis, that is why we are doing the analysis, which are the stakeholders that will be informed about the analysis that we are performing. But at the same time, within this first step, we are going also to identify, for example, the system boundaries, the processes that we are going to compare, and the functional unit. So it is a very important step in which all these aspects are defined and give the possibility then to start with the analysis in step 2. And step 2 is another key point of the analysis, since during step 2, within the life cycle inventory analysis, all the inputs in terms of, for example, material used, energy consumption, and also regarding released wear and waste for the entire life cycle of the product and process analyzed are considered. So the idea of step 2 is in collaboration with all partners that are developing the technical solution to collect all these inputs that are the basis for the life cycle impact assessment in step 3. And in step 3, all these inputs and outputs of the processes are converted in environmental impact. So in step 3, there is the calculation of the impact from the environmental point of view and related to the different impact categories that I've explained before. So, for example, climate change or human health or resources consumption. And the last step is dedicated to the results interpretation. So when the analysis has been concluded, the idea of this step 4 is to identify which are, for example, the measured impacts of the project, which are the measured benefits, and identify which could be the further improvements that could be put in place to increase the project, for example, project efficiency and reduce the project environmental impacts. The approach that we have used within the NEMOSINE project for the performing of the LCA is the comparative analysis. So what we have done is we have compared the current scenario represented by the cold rooms for storing film with the new NEMOSINE scenarios. And we have considered all the life cycle, the entire life cycle. So going from the raw material production processes to the user phase that is mainly related to the energy consumption due to the cold rooms usage, and the end of life. So we have considered all these aspects in the analysis. Here, an example of the application of the methodology. We are considering here the state of the art represented by the cold rooms. And this is basically the first step of the analysis. So we have identified the process to be analyzed, including all the steps of the life cycle. So as you can see, we have done the analysis both for the refrigerator and the refrigerant, and taking into consideration the refrigerator manufacturing, the refrigerator usage, and the refrigerator end of life, and at the same time the gas manufacturing, the gas usage, and the gas end of life. And for all these steps of the life cycle, we have considered the raw materials used, the energy consumption, the transportation, and pollutants release and waste. So these are all the elements that we have considered in our analysis. This has been defined in step 1. Then in step 2, we have collected all the information about, for example, the quantity of raw material used, the energy consumption, and so on. And in step 3, we have converted these inputs and outputs of the processes in environmental impacts. For example, I've indicated here in the graph the impacts related to the energy consumption, with particular reference to the greenhouse gas emissions intensity of electricity generation. So just to give an idea of how the electricity used within, for example, the standard process is then converted in CO2 and give us the possibility of assessing the climate change, the impact on climate change category of the new product, thanks to the, for example, reduction of energy consumption. In parallel with the LCA dedicated to the environmental aspect assessment, we have also performed a life cycle costing. So to assess the, let's say, the economic aspect of the project and to guarantee the project results exploitation. The objective of the life cycle costing is the systematic evaluation of the economic cost associated with a product or a process, including not only the direct cost, but also some external relevant costs and benefits. For example, those related to the CO2 emissions. And the life cycle costing is applied in our project to calculate the economic impacts of the new packages and technologies developed within the project, considering the entire life cycle. And also in this case, we have performed a comparative analysis, so taking into account the economic cost of the current scenarios that are the cold rooms for storing films in conventional package, and we have assessed and compared this cost with the NEMOSINE scenarios. So here are the steps that we have considered within the analysis. So we have considered all aspects going from the definition and design of the new technology and the products, the financing, the materials and manufacturing, the installation and assembly, the operation and maintenance, and the dismantling and disposal. So as for the LCA, for the analysis of the environmental impacts, also in this case, we have considered the entire life cycle going from the raw materials to the usage phase to the final disposal phase. And some example of cost that we have considered that are considered for the lifetime of the product are the purchase price and all the associated costs, for example, delivery, installation, insurance, and so on. The operating cost, including the energy, that is one of the most important costs, I'm sure, for the let's say state-of-the-art scenario, but it is important also for the NEMOSINE scenario. The end-of-life cost, such as the decommissioning or disposal, and the residual value. So we are considering also if there are, for example, potential revenues from the sale of product and the end of its life, and the cost of externalities, as I was saying before. It is important also to consider, for example, the cost of the environmental impacts related to greenhouse gas emission, and to calculate these impacts in terms of cost and with an economic impact too. And the last part of the analysis is regarding the social life cycle assessment. So it is very important for a project like the NEMOSINE project that is dedicated to the cultural heritage conservation to assess also the social impact of the project. As already explained before, a huge percentage of the recent European cultural heritage can be found in movies, photos, posters, and slides that have been produced between 1895 to nowadays, and that are made using cellulose derivates. And more than 100 years of visual and audio memories are in serious danger to be lost due to the natural instability of cellulose acetate. So it is very important to have solutions like the NEMOSINE innovation that allow to preserve the cultural heritage and to improve the cultural heritage conservation methods in order to avoid that all these very important cultural heritage for Europe can be lost. Also, European Commission is very interested in this aspect and is pushing towards the creation, development of new solutions for cultural heritage conservation. Since cultural heritage is very important in Europe for European people, for the cultural and creative sector, but also for economic growth, employment, and social cohesion. So it has a very relevant impact on European economic and social aspects. And for this reason, it is very important to develop solutions that can support cultural heritage conservation. And as for the social analysis, also in this case, we have approached the analysis following the social LCA methodology. The approach is always the same, already explained for the life cycle costing and the life cycle assessment, in the sense that the idea is to consider all the aspects of the entire life cycle of the development of the solution, considering the raw material and energy used for the manufacturing of the solution, but also the usage phase and the end of life phase. And the idea is to understand how all these aspects can determine a social benefits for local communities and related associations. So the analysis has been obviously performed in parallel with environmental and economic analysis. And let's say the methodology is going to consider the entire life cycle, and it is important to outline that the impacts on stakeholders, for example, including workers, local community, consumers, value chain actors, and society, have been considered, such as, for example, the working conditions, the health and safety. So all these aspects are very relevant Obviously, in also the aspect of the cultural heritage conservation is a key aspect. The analysis also in this case is comparative, so it takes into account the state-of-the-art methodologies and products, as well as the new products developed within the project. Just as a conclusion of my presentation, these are the, let's say, the next steps that we are going to complete in the next months. We are going to define the impacts on the environment and human health, the cost effectiveness of the solution, and the social benefits, taking into account the latest technical developments of the proposed solution. So we are, the project is still not concluded. We are concluding now also some technical developments, and all these aspects will be considered in the final assessment of the impact of the project from the different point of view that we have seen. So environment, economic, and social. And all these aspects will be essential to guarantee the proper exploitation of project results, since the assessment of the impact of the project will strongly affect the exploitation of project results in the next years. Thanks for the attention. That's all by my side.
Thank you very much, Luigi. In the meantime, we have received some questions in the panel of questions in the chat. So I would like to invite now, let me change again the roles. Okay, thank you, Luigi. I would like to invite all presenters to turn on the cameras and the microphone to start with the roundtables with questions that we have received during the presentations. Susana, we are missing Susana, and then we can start. Susana, okay, yeah. Thank you. Okay, good. So we have received some questions from the attendees. I will read the questions to you. So please, there are some questions specific for Susana and for other speakers. And there are some questions that maybe can be answered by all the teams. The first question is for Susana. Attendee asked, which is the with this new package, that is the NEMOSINE package, how much do you expect to increase the life of the material comparing with the material no storage?
Okay, of course, it will depend on the starting point of the status of the film, of course, but the aim of the project is at least to increase 5 years the life extension of the film in this new packaging or smart packaging. Right now we are making the final validations. We will start to make the final validation in next January in the 3 archives that take part as a partner of this project, and we will have a lot of value information of the life extension on the behavior of the acetic acid absorbers. But the aim is to at least to reach these 5 years of life extension of the film.
Okay, thank you, Susana. I have here another question that maybe can be answered by Andrea or Susana or both together. That is, will be the NEMOSINE package also available for particular users, or it is just designed for archives and other private organizations?
This is Andrea from Basket Plus, and in my vision also on the behalf of NEMOSINE, we are going to try, of course, to be as broad as possible in terms of covering and fulfill all the different sectors and areas. The project has been built obviously around cultural heritage and specifically around film and photography. However, we don't want, using an English expression, to shoot on our foot. So we are not here just to constrain the objective to a specific sector in the industry. So to answer the question, we will start, for film and photography, but the idea is also to open up this solution to other genre, as I said, to even other 3D and other fragile material that need to be preserved. Susanna?
Yeah, totally agree with Andrea. Of course, this is a research and development project, but the aim is to develop a solution, a universal solution, not only for official entities. There are also private collection of films, of picture, of photograph, and so on. And why not? This could be, if this is a good solution, it doesn't mind if it's a private or it's a public collection. It's a useful tool and it's open to all the final end users, I think.
Okay, thank you. That's good to know. I have a question also for Alfredo. So Alfredo, could you explain how is the process of restoring the data from the PyQL films? And I have then another question for you too.
Okay, thank you. How we restore the data from film? That's a very good question.
Yes.
Because people that acquire the system say, okay, I have my data there, how can I get it? Today there is different ways. The first, the interface is very friendly today. So you requesting it is to the platform, where you just use your metadata, and then it triggers a communication to a operator in a warehouse management system on the AVA archive, and they just take the film from a place and they put it in the pickle reader. So the pickle reader is actually the device that exists today to retrieve it. What it does is that it finds the table of content, it goes to the place where it's located, it scans those frames and rebuild the files and put it available. The pickle reader is accessible to the people. We have companies that say, I don't want to be dependent on pickle, I want to have the machine. They can just have it, they put a reader, a film, and they can choose the file and it retrieves. When we're looking in the future, when it's an archaeological process, everything has disappeared, then the parameters to build a reader, to what type of optics, what type of camera, everything is described there, so you can do a basic scanner and then you make the software and then you can retrieve it. But today, in our modern time, is completely at the click of one button.
Thank you, Alfredo, for your detailed answer. I have another question here that maybe you, Alfredo, can start answering, but I would like also to have the feedback from the other panel. Also because during your presentation, Alfredo, you already mentioned something about this. The question is, do you think that the solution of NEMOSINE, PyQL, and AVA are complementary? You say during your presentation that maybe a collaboration could be made relating to sensors, no? Maybe you can also express here your point of view, and also maybe Susanna, Andrea.
Yeah. No, we think could be complementary. We like especially the monitoring part. As I say, we use a very stable base, so we expect not to have the gases like acetate, all the things that the old films has, like the Wienerger syndrome. But it's very important for us to have oxygen and water, the humidity, things that are nice to detect. And even if a new sensors appears, is very modular, so Pro or something can be installed. So definitely it's something that could be of use, and we think is very interesting project, and they are addressing an important part. So yes.
Thank you. Susanna, something to add to that? Something to add?
Well, in fact, for that reason, we invite PQL today in this training because we have the same objectives, and of course, as Alfredo explained, it's very interesting to integrate sensors to monitorize the status of the not only the film but also any other kind of cultural heritage for the preservation. So I think we are quite complementary.
Good, good. Any other comments? Something to add for this question? Andrea?
Well, from my side, I am, like, I would say, a little bit in the middle, because I've been also cooperated with Pickle. I know them very well. They are very, I would say, not only a prestigious company, but very reliable, not only about their business model, but also their solution is really unique. And to me, this approach between NEMOSINE and Pickle, with the support probably of companies like BesKit+ and AIMPLAS in the production and the distribution and in the marketing also strategy to educate people about this solution, I think would be the best way. I always look for alliance, for partnerships, and I think also the fact that my friend Alfredo is here today, it's a testimony of this success. Thank you.
Thank you, Andrea. I have here another question, this time for Luigi. Luigi, for the life cycle assessment that you presented during your presentation, which software and database do you use for the analysis?
Okay, that's an interesting question. Consider that for the performing of the analysis, we refer to database in order to define which are the impacts of the inputs and outputs of the processes for the different impact categories that we have seen, and this has to be made using dedicated databases. We are using within the project the EcoInvent database, that is one of the most used database in LCA. As for this software, we are using the OpenLCA software, that is a software dedicated to the life cycle assessment, but also to life cycle costing and social LCA. So it gives the possibility of assessing all the impacts of the project depending on the specific database that you are using for your analysis.
Okay, thank you, Luigi. So we have another question, but I think I can answer that. Will you share the presentation with the participants? So yes, the presentation will be available in the NEMOSINE website. We will also publish a post in LinkedIn informing about as soon as the presentation will be available. And you will be informed about the progress of the project during the last few months that we still have in front of us, to keep you updated about the progress and the results reached in the project. We plan to organize a final event at the beginning of next year, so hopefully we will have the opportunity to have it physically, maybe in Spain. You will have information about this final event also in our website and in our social media channels. So please keep tabs about the project progress and results. And thank you very much for participating to this webinar. And again, the video will be also available. So if you didn't have the chance to attend today, or you know a colleague or person that was not able, you will have the opportunity to share the link with them. Thank you very much for your time, to all the speakers, to the special guest Alfredo, and to all the partners of the project that are working very hard to reach the expected objectives and the results. Thank you.
Thank you.
Thank you very much.
Okay. Bye.
Have a nice day.
Bye.
Bye-bye.
Bye-bye.
Bye. Thank you.
Thank you.